Good morning everyone. Welcome to the next lecture. Today we are going to introduce another area of mathematics, that is matrix algebra. See, we will discuss here what actually mean by matrix and its various types. See, the term matrix was firstly used in 1850 by the great English mathematician James Joseph Silverstone. In 1858, see, another British mathematician, Arthur Kelly, he started the systematic development of the theory of matrices. Later, see, the physicist Heisenberg used this particular concept to explain the principles of the quantum theory. Though the matrix is actually originated in the study of linear equation, now we have acquired an independent status and they have become very useful in various fields, especially quantum mechanics, mathematical economics, statistics and computer sciences. Today, it is regarded as one of the most powerful and convenient tool in economics and business, especially in social accounting, input-output analysis, game theory, linear programming, and inter-industry economic relationships. Now, the matrix has evolved from their beginning in linear algebra and it becomes an indispensable tool across a wide range of disciplines, contributing significantly to the advancement of science, technology, and industry. See, let me introduce the concept of matrix. Consider a case of two friends, namely, Rahim and Raju. See, Rahim has 2 books, 4 notebooks, and 5 pens. And the Raju has 8 books, 4 notebooks, and 2 pens. A convenient way of representing this information, that is, the information regarding the books, notebook, pen by Rahim and Raju, is represented in a tabular form, which I am showing here. See, here books, notebooks, pens are taken here, Rahim and Raju, and the information here, Rahim possesses 2 books, 4 notebooks and 5 pens, and Raju is having 8 books, 4 notebooks and 5 pens. See, in this particular table form, we can observe that there are 2 horizontal lines. The first horizontal line has numbers of 2, 4, 5 representing the books, notebooks and pen possessed by Rahim. And the second horizontal line, that is 8, 4, 2, which is represented by the books, notebooks and pen possessed by Raju as well. And we also observe that there are 3 vertical lines here, 2 and 8, which represent the books, 4 and 4, which represents the notebooks, 5 and 2, which represents the number of pens. See, the same information we can also represent in another form of table, that is just interchanging the horizontal one into the vertical one and vertical one into the horizontal one. See, now Rahim and Raju is taken here and books, notebooks and pen is taken here. And the same information we are represented by using 3 horizontal lines and 2 vertical lines, that is Rahim and Raju, and the 3 horizontal lines are representing for the books, notebooks and pen. Now, by using this particular table, see, we can represent a form of matrix. See, we are writing that particular numbers in a particular matrix, that is matrix A is equal to 2, 4, 5, 8, 4, 2. Or we can also write in another form, that is 2, 4, 5, 8, 4, 2. Or we can also write in just opposite of that. See, here we have a 2 horizontal lines, but here we have 3 horizontal lines and 2 vertical lines. See, the arrangement given table, which is generally shown here, which we can say that it is a matrix. And each number, or we can say that the parameters, or it is the variable given in a matrix is actually refers to as element of matrix. And the numbers in the horizontal line 2, 4, 5, 8, 4, 2. See, these are called rows, and the numbers in the vertical line are generally called it is the columns. So usually we denote a matrix by using the capital letters, that is A, B, C, like that, and which are arranged in a square bracket. See, either we are arranging in a square bracket or by using, this is known as large parenthesis. It is a large parenthesis. So thus we can say that a matrix is a rectangular array of numbers, parameters or variables, each of which we are carefully ordered in the form of horizontal and vertical lines. Or we can say that they are arranged systematically in rows and columns. I hope it is clear to you. Now look at the dimension of matrix. See, the dimension of matrix means how many rows and columns are there in a given matrix. See the numbers of rows which generally showing that it is R, and the numbers of columns which are generally representing in terms of C. See, we can say that here the dimension it is R by C. We can say that it is R by C. For example, here we have a matrix A which is equal to 1, 2, 3, 1. See, this is an example of 2 by 2 matrix. In this we have 2 rows and 2 columns. We have 2 rows and 2 columns. That's why we are saying that it is 2 by 2 matrix, or the dimension of this matrix is 2 by 2. Consider another one. See, we have here 3 rows and 2 columns are there. We have 3 rows and 2 columns are there. So we can say that this dimension is here. It is 3 by 2 matrix. It is 3 by 2 matrix. Consider another one. Matrix A is equal to 3, 0, 5, 4, 1, 2. See, here we have 2 rows and 3 columns, and we can say that the dimension of this matrix is 2 by 3 matrix. And similarly, we have the last matrix shown here, that is matrix A is equal to 5, 1, 8, 2, 5, 6, 3, 9, 8. See, here we have 3 rows and 3 columns are there, and we can say that the dimension of this given matrix is 3 by 3 matrix. Now see the general form of a matrix A having m rows and n columns, which can be represented as, see, matrix A is equal to A11, A12 up to A1n, and the second row which showing that A21, A22 up to A2n. And if you go for extending the rows, then we have up to AM1, AM2 up to AMN. See, here in the given matrix, it is A11 which actually showing that it is the element which belongs to first row and first column. First one showing that it is first row and the first column. Similarly, for example, A22, which showing that it is belongs to, this particular number is belongs to the second row and the second column. And similarly, for example, we can consider AMN, which represent that this is mth row and nth column. And in the same way, we can represent and define the other one also. See, here it is A12. This is the first row. This element represent, this is in the first row and the second column. So thus we can say that the order or dimension of this matrix is m by n matrix. Thus we can say that in simple way, a matrix is a rectangular representation of elements or numbers which are arranged systematically in rows and columns or in the form of horizontal and vertical lines. Now, we can discuss different types of matrices which are basically categorized on the basis of value of their elements, their orders, number of rows and columns, etc. Let us consider some of the types. The first one is, see, it is row and column matrix. See, it is row matrix, or it is also known as it is row vector. See, a matrix is having one row only. then such a matrix is known as row matrix. It have only one row. So the order of row matrix is always 1 by R, and it is also known as it is a row vector. For example, see here we have matrix A is equal to 4, 6, 1. See here we have only one row. So we can say that it is a row matrix. If we have only one row, then we can say that it is a row matrix. Consider another one, column matrix. A matrix having one column only, then such a matrix is known as column matrix. And the order of the column matrix is always C by 1. And that means it has m rows but only one column is there. So it is also known as it is a column vector. For example, matrix A is equal to 3, 1, 9. See here, this is we have only one column here. That's why we can say that it is a column matrix. Now consider the another type of matrix which is known as square matrix. A matrix having the number of rows equal to the number of columns. That means the number of rows is equal to the number of columns, then such a matrix is generally known as it is a square matrix. And a matrix of R by R is called a square matrix or R rowed squared matrix. For example, see we have a matrix A, B, C, D. This is a square matrix of order 2. We can say that it is 2 by 2 matrix, or we can also say that it is a 2 by 2 matrix, or here the order 2. Similarly, we have another example of a square matrix A, B, C, D, E, F, G, H, I. See, we have 3 row and 3 column. We can say that it is a square matrix of order 3, or it is the 3 by 3 matrix. It is a 3 by 3 matrix. Now we have another type of matrix which is known as rectangular matrix. A matrix in which the number of rows is not equal to the number of columns, which is generally known as it is rectangular matrix. See, arrangement of the element in the matrix is in the rectangle shape, because here the number of row is not equal to the number of column. So that's why it is called a rectangular matrix. For example, matrix A is equal to 2, 4, 2, 3, 5, 3. See here, we have the 2 row and 3 column are there. So in this case we can say that a row is less than column or row is greater than column. Then it is generally called as a rectangular matrix where the number of rows is not equal to the number of columns. Here the matrix B is given. See, we have 3 row and 2 column are there. So if the number of row is not equal to the number of column, so it is generally known as it is rectangular matrix. See, it's showing a rectangular shape. That's why this type of matrix is generally known as it is rectangular matrix. Now we have another type of matrix. See here, it is diagonal matrix. If all off diagonal elements of a square matrix are 0, then that matrix is known as it is diagonal matrix. See, if all elements except the principal diagonal in the square matrix are 0, then it is known as it is a diagonal matrix. For example, consider the matrix A, that is 5, 0, 0, 0, 2, 0, 0, 0, 3. See here the diagonal elements. See, these are the diagonal elements 5, 2, 3. These are the diagonal elements, and all the elements, other elements are non-diagonal elements. So here the diagonal elements 5, 2, 3, but each of non-diagonal elements are 0. So such a matrix is called a diagonal matrix. A special thing is here, see, all the non-diagonal elements of this matrix are 0. And that means only the diagonal elements, that is 5, 2, 3 are, has non-zero elements. Most important things, especially you have to note down, that is diagonal elements is, or diagonal matrix is always a square matrix. And a matrix can have only one diagonal. See, only one diagonal, and non-diagonal elements of this matrix are 0. So such a type of matrix is known as it is diagonal matrix. Now we have another one, that is triangular matrix. See, it is also a square matrix in which all the elements above and below, not both, the diagonal matrix are 0. Such a matrix is known as a triangular matrix. See, even in the case of a triangular matrix, we have two kinds of a triangular matrix. We can say that we have a lower triangular matrix and upper triangular matrix as well. See, a lower triangular matrix, if all elements above the diagonal matrix are 0, if all the elements above the diagonal matrix are 0, then such a type of matrix is known as it is lower triangular matrix. Let us consider one example. See, matrix A is equal to 5 0 0 1 2 0 4 2 3. See here, all the elements above the diagonal, this is the diagonal elements, that is 5 2 3. So above the diagonal elements, that is 0 0 0 are 0, then we can say that this is a lower triangular matrix. See, as against the lower triangular matrix, we have an upper triangular matrix as well. See, if all elements below the diagonal matrix are 0, see, then we can say that it is upper triangular matrix. For example, matrix B is equal to 5 1 4 0 2 2 0 0 3. See, this is the diagonal element, that is 5 2 3. This is the diagonal element. So below the diagonal elements, see here 0 0 0. So if all the elements below the diagonal matrices are 0, then we can say that it is upper triangular matrix. So this is, we can say that it is an upper triangular matrix of order 3 by 3. This is lower triangular matrix by 3 by 3. Now we have another type of matrix which is known as scalar matrix. If the diagonal elements of the diagonal matrix be all equal or the same, then the matrix is called a scalar matrix. See, consider one example. Matrix A is equal to 5 0 0 0 5 0 0 0 5. See, all the diagonal elements of this diagonal matrix, of course it is a diagonal matrix because all of diagonal elements are 0, but the diagonal elements of the diagonal matrix are same here. It is 5 5 5. So such a type of matrix is known as it is scalar matrix. So in this matrix, the diagonal elements are equal, that is 5. So such a square matrix in which every non-diagonal elements is 0 and all the diagonal elements are equal, then it is the square matrix where all the diagonal elements equal to a constant scalar or constant value and all other elements are 0. So such a type of matrix is generally known as it is a scalar matrix. Now consider another one, a unit matrix or identity matrix. See, if all diagonal elements of the diagonal matrix are equal to 1, then it is generally known as it is unit matrix or identity matrix. See, consider one example. We have a matrix A which is given as 1 0 0 1 0 1 0 0 0 1. See, all the diagonal elements of the diagonal matrix are equal to 1. Then such a type of matrix is known as it is unit matrix or identity matrix. See here, all the elements of the diagonal matrix are equal, and such a square matrix in which every non-diagonal elements is 0 and all the diagonal elements are equal to 1. Then it is known as it is a unit matrix or identity matrix. Consider another type of matrix which is known as zero matrix or null matrix. If in a matrix all the elements are 0, then it is called a zero matrix, and it is generally denoted in terms of, it is 0, which is equal to, see, 0 0 0 0. It is a 2 by 2 matrix, but all the elements here is equal to 0. This is a 3 by 3 matrix. Here also, see, all the elements are 0. So such a type of matrix is generally known as it is zero matrix. Now we have equal matrix as well. See, we can say two matrices, matrix A and B, are said to be equal if they are same order and the corresponding elements are equal. Then we can say that it is an equal matrix. What are the conditions? They are the same order and the corresponding elements are also equal, then we can say that it is an equal matrix. Consider one example. Matrix A is equal to 3, 4, 1, 2 and matrix B is equal to 3, 4, 1, 2. See here, order is same, that is 2 by 2 matrix, and the corresponding elements are also equal. Then we can say that matrix A and matrix B are equal matrix. Now we have idempotent matrix. See, a idempotent matrix is generally a symmetric matrix. It is a symmetric matrix that reproduces itself when you go for multiply a matrix A by itself. Then we can say that it is an idempotent matrix. That means matrix A will be termed as an idempotent matrix. See, when a matrix A into the same matrix A, which is equal to, it will reproduce the same matrix, that is A. So it is A into A which is equal to A, which means that such a matrix reproduces itself when you go for multiplying a matrix by itself. For example, see, matrix A is equal to 1, 0, 0, 1, which is an example of an idempotent matrix. How? See, if you go for multiplying this matrix with the same matrix, then see here, it is again reproducing, it is also equal to 1, 0, 0, 1. So if it is reproducing itself a particular matrix, then we can say that it is an idempotent matrix. The important character is that is A into A which is equal to A. Now consider the another type of matrix which is generally known as it is transpose of a matrix. We can find the transpose of a matrix especially by obtaining, interchanging its rows into columns and columns into the rows, which is generally denoted AT, that is A raised to the power T, which is read by it is transpose of a matrix A, transpose of a matrix A. So it is simply a flipped version of the original matrix. So we can find the transpose of a matrix is a new matrix which generally obtained by interchanging the rows and columns of an original matrix. Consider one matrix, that is matrix A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. This is a 3 by 3 matrix and we can explain these elements as well. A11 showing that it is the first element in the first row, first column. Similarly, A33 which showing that it is the third row and third column. So then we want to find out the transpose of this given matrix. Then what we are generally doing, we are denoting it is A transpose. Then we are going to interchange each row into the column and each column into the row. So this is the first row, here it is A11, A12, A13. So I am going to write this particular horizontal or the row, first row into the column. So it will be A11, A12, A13. Similarly, I am taking the second row and here I am writing in the form of column wise. See, it is A21, A22, A23. Third row I am going to write in terms of columns, then see it will become A31, A32, A33. So by using this particular way, that means interchanging rows into columns and columns into rows, we can find the transpose of a matrix. Consider one example. We want to find out the transpose of a given matrix. What is the given matrix? Matrix A is equal to 2, 4, 2, 3, 5, 3. Then if you want to find out the transpose of this given matrix, then we are just going to interchange rows into columns and columns into rows. So here we have 2 by 3 matrix because we have two rows and 3 columns. So if you go for finding the A transpose, which is equal to, I am writing the first row as here in the first column. Here the second row I am writing in the form of second column. Second row I am writing in the form of second column. So it will become, see, A transpose will become, see here it is 2, 3, 4, 5 and 2, 3. So in this way you can find the transpose. Consider another one, matrix A is equal to 1, 2, 5, 2, 3, 4, 2, 8, 6. And we want to find out the transpose of this matrix. Then we are just going to interchange the rows into columns and columns into rows. Then here it is 1, 2, 5, I am writing here in the form of column. 2, 3, 4, I am writing in the form of the second column. 2, 8, 6, the third row which I am going to write here, it is the third column, 2, 8, 6. So in this way, you can find the transpose of a matrix. So simply the transpose of a matrix you can obtain by interchanging rows into column and columns into rows. Now consider another type of matrix which is known as symmetric matrix. See, a square matrix is said to be a symmetric matrix if it remains unchanged by interchanging its rows and columns. So as we are already said that if you are going to interchange the rows into column or columns into rows, then it will become a transpose of a matrix. So here what we are saying, a symmetric matrix, it will remain unchanged by interchanging rows and column, then we can say that it is a symmetric matrix. So in other words, we can say that a square matrix is said to be a symmetric, then matrix such that the transpose of a matrix is equal to its original matrix. So for example, here we have a matrix A which is equal to 1, 0, 0, 1. Now we are going to change the rows into columns and columns into rows, which means that we are going to find the transpose of this given matrix. Then it will become, see again it reproduce 1, 0, 0, 1. So then we can say that this type of matrix is a symmetric matrix. Similarly, consider another example. Matrix A is equal to 1, 2, minus 3, 2, 0, 4, minus 3, 4, 6. We have a 3 by 3 matrix. If you go for interchanging here the columns into rows, then it will become, see, 1, 2, minus 3. 1, 2, minus 3, 2, 0, 4, 2, 0, 4, minus 3, 4, 6. I am going to write in the third column. See, both are looking the same way. That means here the transpose of the given matrix is also equal to the A. Then such a type of matrix is known as, it is a symmetric matrix. Now as against the symmetric matrix, see we have a skew symmetric matrix. It is a square matrix, or we can say that a square matrix is said to be a skew symmetric matrix, or it is also known as anti-symmetric matrix if it changes only sign by interchanging its rows and columns. If you go for interchanging rows into the columns and columns into the rows, then only sign will going to change. So such a type of matrix is known as, it is the skew symmetric matrix. In other words, a square matrix is said to be skew symmetric, the matrix such that whose transpose is equal to its negative. That means A transpose is equal to minus A. For example, matrix A is equal to 0, minus 10, 10, 0. If you go for taking the transpose of this given matrix A, then it is equal to 0, 10, 10, 0. See here only sign is changed. Here it was minus, now minus is changed to here. But there is no other changes is happened. Similarly, for example, consider another type of matrix A which is equal to 0, minus 2, 3, 2, 0, minus 4, minus 3, 0, 4, 4, 0. If you go for taking the transpose of this matrix by interchanging rows into columns and columns into rows, then see it will become 0, 2, minus 3, 2, 0, 4, 2, 0, 4 here, minus 3, 4, 0, minus 3, 4, 0. See here, just to observe here, we can understand that only sign is changed. The number is remain constant. So such a type of matrix is generally known as skew symmetric matrix. So skew symmetric matrix is such a matrix that we have only changing the sign if you go for interchanging rows into columns and columns into rows. So let me conclude here. Today we have discussed what actually mean by a matrix, where we defined matrix is an rectangular array of numbers of each of which has carefully ordered in the form of rows and columns, or it is vertical line or horizontal lines. So then we are enumerated what are the various types of matrices along with suitable examples. I hope it was clear to you. In the next lecture we will start our discussion on the operations of matrices. So we'll see in the next lecture. Thank you.